Hello, grade 11s and grade 12. In today's lesson, we're going to be looking at drawing free body diagrams. And without any further ado, let's just get right down to the lesson. So, in starting with the lesson, we're going to be looking at some definitions so that we understand why some forces may be or may not be present in some particular situations. So starting off, we have normal force. We say this is the force that is exerted by the surface on an object and acts perpendicular to the surface in which an object is placed. That is to tell you that the normal force will only be present if an object is placed on a particular surface. Because remember, normal force is the force that is exerted by the surface. So if an object is just hanging, not on any particular surface, it cannot experience normal force. Then, okay, we have gravitational force or weight. We say this is the force exerted by the earth at the center of the object and always acts downward. So this force is experienced by every object on earth, right? So every object has mass and occupies space. It is matter and therefore will experience gravitational force. Then we have the applied force. This is a push or pull on an object. So if it is indicated that an object is being pushed or pulled, then you know that you have to include that applied force. Then we have tension force. This is the force exerted by rope, string, or cable on an object. So if you say rope or string or cable attached to a particular object, then there is tension force. We have frictional force. We say this is the force that opposes the motion of an object and acts parallel to the surface. So this is the force that will always oppose the motion of an object. If your object is going to the right, the frictional force will act to the left. If your object is going to the left, the frictional force will act to the right. Now we have to understand that we have two kinds of frictional forces, which are the kinetic frictional force and the static frictional force. What is kinetic frictional force? Coming from the word kinesis, we know kinesis means movement. So this is the force that opposes the motion of a moving object relative to the surface. So this one will always oppose an object that is in motion. Then static frictional force, this is the force that opposes the tendency of motion of a stationary object relative to the surface. So this kind of friction will always oppose the motion of a stationary object. Now we do understand that every object is in perpetual motion. It wants to move, but the reason it's not moving is because it is held in place by the maximum static friction. Unless that maximum static friction is overcome, then the object will not move. It will start moving when we overcome the maximum static friction. Hence we say this is the tendency of motion of a stationary object. Okay, now let's look at the situations that we are given here and start to draw free body diagrams. So number one, we have an object lies motionless. So if an object is lying motionless, we do understand that here the object is just placed, it is not moving in any direction, right? So what are the forces that are experienced by this object? Let's check now. The forces that are experienced by this object, it is always advisable to draw the obvious ones. So we know gravitational force is always present there because this force is on earth, and then it is experiencing gravitational force. Then we also have the normal force. Why? Because this object is placed on a surface. So we understand that the surface will be exerting a force on this object. So we have the normal force and the gravitational force. And you should always note that these two forces should be equal. So your upward force and your downward force should be equal. So I know maybe they might not look as equal, but then you get the idea. The normal force and the gravitational force should be equal when an object is placed on a horizontal surface like that. Now let's look at number two. They say the object is pulled by a force parallel to the surface and there is no friction. So we understand now that there is an applied force because there is a pulling, right? Remember, applied force is a push or pull on an object. So what are the forces that we have here? We have the gravitational force, which is always acting downward, And since this object is on a surface, the surface exerts a force which is the normal force, and then we are told that this object is being pulled to the right by a force, so we indicate that applied force here. So force applied like that, and that is your free body diagram. Now number 3, it says the object is pulled again by force parallel to the surface, but this time we have friction. With the friction, so what are we supposed to have here? Again, we know that we have gravitational force, which is always acting downward and upward there. Balancing that gravitational force is the normal force which is exerted by the surface on an object. And then we have the applied force acting to the right, the object is being pulled. Then we know that since they said there's friction, the friction will always oppose the motion of an object. So now we know that if a force is applied to the right, the object will obviously slide down to the right. Therefore, the frictional force will be acting to the left, opposing that motion, right? So why is my kinetic frictional force small? It's because now we are saying if this object is pulling, then we are assuming that the object is moving to the right, and therefore that means the force applied is greater than the kinetic frictional force, right? Now number 4, an object is suspended from the ceiling. We can see that it is connected to a string or a rope there, so we know that's tension force. But then the obvious force that we have there is the gravitational force, which is always acting downward. So we start with the gravitational force, and up there what do we have? Have the tension force. And since we can see that this object is being suspended, meaning it is held stationary there, we should indicate that the tension and the gravitational force, they are equal, since we can see that this object is at equilibrium. Number 5, they say an object slides at constant speed across a surface without friction. So this object is going to the right like that, and they're saying it is just sliding at constant speed across a surface without friction. I know with this one it is very tempting to say that there's an applied force, but remember, if an object is just sliding down, there is no applied force. We just assume that there is no force that has been applied to it because we are not told that this object was pushed or pulled, right? So now the only forces that we're going to have here is your gravitational force Fg and the normal force, right? So these are the only forces that are here. The object is just sliding down on its own, right? Then the normal force and the gravitational force are equal. Number 6, it says an object slows down while moving across a surface due to friction. So as this object is moving to the right, it is slowing down due to the friction because of that rough surface there. So what are the forces that we have here? The obvious ones are your gravitational force acting downward, and then since this is on a surface, we have the normal force, but then here the object is moving to the right. That means the kinetic frictional force will have to act on the left of the object, right? The object is moving to the right, therefore the kinetic frictional force will be to the left. Number 7, it says an object accelerates as it slides down a frictionless incline. The object accelerates as it slides down a frictionless incline. So the object is going downward like that. Now to draw free body diagram for objects on an incline, you can start by faintly drawing that incline so as to assist you in drawing your free body diagram. Then what do we have here? Let's indicate this. Now see what will happen with your normal force. Remember, when we define normal force, we say this is the force that is exerted by the surface on an object and always acts perpendicular to the surface. Now you do understand that the surface is now inclined. So that means your normal force can no longer act vertically upward like that, because if you can check here, the force here will no longer be perpendicular to the surface, since the angle it will form there will be an obtuse angle. That means right now when you have your object on an incline, also your normal force should slant like that, forming a 90-degree. So let's draw the normal force. The normal force this time should look like this, because we say the object is on an incline. If you can just check the angle it forms with the surface here, you can see that it is still perpendicular to the surface. So always note that the normal force needs to be perpendicular to the surface, whether the surface is horizontally or the surface is an incline, needs to be perpendicular to the surface. So you see how the normal force will be like this time, since we have an inclined surface. So, but what happens to our gravitational force? Our gravitational force still maintains its definition. It always acts downward. So that's our gravitational force like that. But then you've been taught to resolve, right? So if you are to resolve this, the gravitational force to its components, then you know that your FG parallel should always slide down the surface. So let's indicate that with a green. So your FG parallel always slides down the surface. So if the surface was going in that direction, your FG parallel will also be sliding down to that direction. So the FG parallel is always sliding down the incline. Then in line with your FN, also perpendicular to the surface, will be your FG perpendicular. So in line with the normal force is your FG perpendicular, which you can see it will also form that 90-degree with the surface. So that's how you have your free body diagram. If you are not to resolve it, then you have your normal force like that and your FG like that. But if you are to resolve it, then you'll also have your FG parallel and FG perpendicular. Note that when you are resolving, there is no need to include that gravitational force again, since we know that the FG parallel and the FG perpendicular will be representing the gravitational force. So these two components have the same effect as the gravitational force alone. Then an object is held motionless by a rope on an incline. So let's draw for this one. Again, let's faintly show that incline. Just faintly show that incline. And then let's draw. We have the normal force, which should form 90-degree with the surface. So as you can see there, we have it being perpendicular to the surface, and then down, acting downward, will be our gravitational force like that. And then what do we have there? We have a rope, right? So this is held stationary or motionless by that rope. So we need to indicate the tension force up there. So we have tension force. Now, if you are asked to resolve your gravitational force, sliding down, use your FG parallel, and straight in line with normal force, it's your FG perpendicular, also perpendicular to the surface. So that's how you have your free body diagram. Mentioned here, yes. Number 9, they say an object is motionless. So you can see that object is motionless, but then it is motionless on an inclined surface. Now we do understand that if we place an object on an incline, we expect it to slide down on its own to the ground. But then the reason this thing is not happening here is that we have a rough surface. So if we have a rough surface, we know that the object is motionless or it is not moving due to static frictional force. So you can see with this question or this situation, we are not told that there is static frictional force, but then we know that if we place an object on an incline, it should slide down. The reason it is not sliding down, it is because it is held by static friction. So having to draw the free body diagram there, faintly showing the incline, we will have the normal force perpendicular to the surface, forming that 90-degree with the surface. Then we have our normal force. So let me draw it nicely. So forming that 90 degrees our normal force. Then acting downward is our gravitational force. Yes. Then now we understand that they said that this object is held motionless, but then we do understand that it is held motionless by static friction. So we need to indicate that static friction up there. So why do we indicate that static friction up there? Because remember, it is opposing the motion. We are expecting this object to be sliding down, but then it is held stationary there. That means the static frictional force is acting upward, right? So until we overcome that static friction, that maximum static friction, then the object will start to slide down. Now, if you are to resolve FG parallel, will be acting downward, and straight in line with your normal force will be FG perpendicular. And that's how you have your free body diagram. Okay, number 10, they say an object slides down an incline at a constant speed. So here, there is no force applied. The object is just sliding down at its own accord, right? So having to draw the free body diagram here, faintly show the incline. So you can erase this after, right? Then it's just to assist you to draw your free body diagrams correctly. Then we have 90-degree here is your normal force perpendicular to the surface. Then sliding down is your Fg. Acting downward is your Fg gravitational force. Then there is no force applied, and we are not told that there is friction, right? But then let's assume that there is friction in our case, just for interest's sake. Let's assume that there is friction now. So if there is friction, what will happen? We know that the friction will oppose the motion. The object is sliding down. So frictional force will be this side Fk, kinetic frictional force. And then if we are to resolve this, we have that sliding down, it's our Fg parallel. And then straight in line with your normal force, it's your Fg perpendicular. So that's how you'll have it if there's friction. But if they say there is no friction, we'll just come here and erase this. So that's how you'd have it.